In this demonstration, we'll investigate a real-time anonymized data sample from a peer-to-peer or P2P payment platform, identify fraud patterns, resolve high-risk fraud communities, and apply recommendation methods. We will identify new fraud risks that went undetected with non-graph methods, increasing the number of flagged users by 87.5%. The graph schema in this will consist of credit cards, devices, and IP addresses. And each user node has an indicator variable for money transfer fraud named MoneyTransferFraud that is marked as 1 for known fraud and 0 for otherwise. This indicator is determined by a combination of credit card chargeback events and manual review. Currently, PuppyGraph can be launched in two main ways. The first way is through Docker, which is going to allow you to run PuppyGraph anywhere that you can run Docker. Secondly, you can also launch PuppyGraph through the AWS Marketplace, and soon you'll be able to launch PuppyGraph through the GCP Marketplace as well. Today, I'm going to show you how to run it in Docker. So for Docker, you can simply come to our PuppyGraph docs, click Getting Started, launching PuppyGraph in Docker, and then following our step-by-step tutorial here is just a couple steps. First, you'll need to make sure that you have Docker installed. Then, after Docker is installed, you'll then start a PuppyGraph container using this command. Just one note is that this command means that when your container is stopped, based on this --rm flag, this is going to completely remove the PuppyGraph instance. If you want to keep the instance so that you can start and stop it, just remove this -rm flag. Of course, if you want to make further tweaks to this run command, you can do that as well as needed. Once you run this command, the PuppyGraph image will be pulled down, and then the system will boot up. Once you've got PuppyGraph up and running, you can then proceed by logging into it. The default credentials will be PuppyGraph as the username and PuppyGraph123 as the password. Our next step, once we've logged in, is to upload our graph schema JSON. Now, there's other ways to do this as well. We can also use the create graph schema functionality, which is going to allow us to connect to a data source and then use the UI to design the graph schema. Or if you don't have a schema, you can also use one of our example schemas as well. That being said, today what we're going to do is use a JSON file that contains our catalog connectivity details, as well as how to map the data from our SQL data source over into PuppyGraph. Now, what does that JSON file look like? Well, here's an example of a fraud dataset hosted in Iceberg that we're going to use to populate our graph in PuppyGraph. At the top of the file, which is named fraud_iceberg.json, we can see our first entry here will be catalogs, and this is going to contain some info around the data source that we're going to connect to. So you can see here we've got the name, the type, and then we've got metastore information. As you can see here, I've got a few things around the security and the URI for the source itself. And this here is all that's needed to connect to that data source. Now, if I have multiple data sources, I can do that as well, because as you can see, this is an array. And just underneath this catalogs entry, you can see that I have vertices or nodes. You can see that I've got an array of nodes here. Here's my first node, which is user. You can see my mapped table source showing which catalog this is coming from, the schema, the table, and then the meta fields that are involved in this specific node. Then you'll see attributes, which are where I define the attributes for the node itself, and this will be pulled from the SQL data source. You can see I've also got card here, same thing, map table source, attributes, device, IP, and then just underneath this, you'll see I've got an array of edges. Here we have use device. This is the mapped table source, very, very similar to what we looked at with nodes or vertices. But here you can see that we have a to and from, which are going to allow us to map this edge in relation to the nodes that it would connect to. We also have attributes that you can attach to this edge as well. You'll see that I have some further edges here, P2P, referred, has card, has IP, and this is our schema. And we're going to upload this next into PuppyGraph, and this is going to allow us to take this data in Iceberg and map it into a graph. So in PuppyGraph, I'm going to choose the file that I want to upload as the graph schema. I'll click upload once I've selected that file. And this is then going to push the schema to PuppyGraph and begin to map that data from the SQL data source into the graph. So as you can see, that schema is now here in PuppyGraph. I can see my nodes. I can also see my edges, such as use device, has card, has IP, P2P. And now we're able to go ahead and start querying this data in the underlying SQL data source as a graph. To do that, I'm going to click on Query. And the first thing that I'm going to do is run a query in this Gremlin query console. We also have Gremlin console as well, Cipher console, and we'll run a query here so I can show you that as well. And we also have the ability to run queries within Graph Notebook as well. First, I'm going to run a Gremlin query that's going to identify any confirmed financial fraud users. We're going to get any node that has user and also has fraud money transfer as true. So I'll click this, and now here are all of our user nodes that have confirmed financial fraud. If I want to explore each of these users, I can click on them, and you can see here that fraud money transfer is equal to 1. And I can see some other things associated with these as well. So this is, of course, a very simple query for me to run, but let's run something slightly more complex. Next, we're going to run a query to find if there are confirmed fraudulent users within a specific group. So here we have user has fraud money transfer and has a WCC ID of this number here. And this is going to be a weakly connected component ID. Now let me run this. Now first, let's clear our result over here, and then I'll run this query here. So within this group, we only have one user that would be considered fraudulent. Now, because of the way that this visualization works, I can right click here and I'll do expand with all edge labels. Now I'm able to explore this even further, such as this outgoing edge that goes to a specific device. I can also look at IPs that are associated with this specific user. I can also explore the edges as well by clicking on them. And if I wanted to go further, I could also right click on these and click expand with all edge labels. And as you can see, I can slowly build out this visualization, and the corresponding queries that are being run are over here on the left panel. Now I want to run one last query. I'll click clear, and I'm going to run a query to find users within a specific group. And if there are confirmed fraudulent users in the group, we may also want to discover if other users in the group may be fraudulent as well. So we're going to run essentially the same query that we ran before, except we're also going to add a .out and use this pattern association edge. I'll run this query, and here we can see some of the relationships between the users. So these are potential other fraudulent users that are associated with that specific group. Just like the previous example I showed, I'll right click on this again, and similar to last time, we can also do expand with all edge labels. However, if you have a specific edge label that you want to expand on, you can do this as well. Now I'm going to click expand with all edge labels just so we can see everything for illustrative purposes. Now we can see other connections to this specific user as well. Now if we want to look at this slightly differently, currently we're looking at it in radial layout, but I could also look at it in vertical layout, which is going to give me a different view of the relationships within this data. I could also look at force layout, and this is going to give me different ways to be able to explore this data visually. Now I could also click Cipher console, and let's say I wanted to establish a relational pattern based on the following criteria. One user transfers money to another user who shares the same credit card. Now my results here are going to show me any users that transfer money to each other and share the same credit card. Now I could also run another query here to check group accounts with transfer records and shared credit cards using the weakly connected component algorithm. And for that, I'll scroll down to the bottom and here run that query. And then I'll be able to see the output as well for that. So this gives you visual support for Gremlin queries, the Gremlin console as well, Cipher support, and Graph Notebook support. Alternately, we also are able to explore visualizations using the Visualize tool, and I can see within my dataset the amount of connections between nodes and edges by exploring these from this more traditional graph approach. Now I am able to also search for a specific node here, zoom in and out, and if I click on a node, I'll be able to see all of the edges it connects to as well. If I right click, I can then see more information on the node, including labels, and in this case, a GUID. If there are specific queries that I want to put into a dashboard, I can use that. I can do that as well in PuppyGraph. By default, you'll see my dashboard here has a vertex count, an edge count, a vertex labels table, and then a graph visualization sample, as well as this vertex samples pane as well, where you can see everything to do with a specific node. Now, if I wanted to take one of the queries that I ran previously and add that to the dashboard, I could come down to the bottom, click plus, I'll click edit, and we'll call this confirmed financial fraud users. Then I'll paste my query in here. Then I can pick my display type, either as text, graph, or table. For this one, I'm going to pick graph. Then my graph layout, I'll keep as radial. However, the other ones I showed you previously with vertical and force are also applicable. And then we can also do scale to fit, which I'll click off and then click submit. And as you can see, I've got my new pane that shows my result of 243 notes. Of course, just like the other visualization tool, I can also explore things a bit further here as well. And with that, we've brought in a bank fraud detection dataset and ran various queries against that dataset as a graph. And then we also went further and added some of our queries to a dashboard. For more information on how you can get started with PuppyGraph, visit www.puppygraph.com.